Now, Dave, uh, I think you explained it pretty well about how this establishes trust between the end user, the end environment, and the source code itself, or the deployed code, I should say. But this whole series of trust, what are some of the ways that it can go wrong? How can code signing go wrong?
Well, there's a few ways, right? So while the process seems like, hey, that'd be a great idea, I just sign this, people know it's for me. What could go wrong? What can go wrong is if somebody impersonates you. So let's say someone's able to gain access to the signing key, right? And now I can take that signing key and I can create a piece of malware. I can use your signing key to sign that malware and I can distribute it. And people will look at it and go, okay, it looks like an update from, EnTrust. It's digitally signed. It's digitally signed by them, so I trust it. Unfortunately, that again, if that key is compromised, then um, the code that's being signed isn't really the code that you want signed and you want with your name on it. And to kind of combat that, there's a lot of processes that can kind of go around protecting that key or protecting the process of how that key is used. So that's usually when we're talking to customers, they're that's their biggest concern, is making sure that someone isn't signing something that shouldn't be signed, because that's their name, it's their brand, it's their trust.
So
So
just briefly there, I saw a new word in this that I've never heard. Cryptographic hash.
yes,
That's that is
so
definitely a new one.
yeah, it's think of it like a fingerprint, right? So it's unique to every piece of code. There's cryptography behind it to calculate that, what that string of digits is, but essentially it acts as a fingerprint, right? So I don't have to sign, a piece of code that might be, hundreds of meg uh, large. I just have to get a fingerprint of what that code is, and I can sign that fingerprint, which is much, much smaller.